Hello, everyone. We'll get started in just a couple minutes. All right, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are going to discuss an overview and breakdown of regression models. So I'm going to go through the entire presentation first. And if you have any questions, you can type those into the chat box or the question and answer box. And at the end of the session, I will be doing a question and answer session. My colleague Melissa will be assisting me with questions during the webinar. So if you have any questions about our company and the services we can provide, you can put those questions in the chat box and Melissa can guide you in the right direction. All right, and we will be sending everyone a recording of the session as well as a copy of the PowerPoint. So today, I'll give a brief overview of the services that our company provides. Then we will dive into the topic for today, which will be discussing the different types of regression models. I'll then give a demonstration of a regression in Intellectus Statistics, which is our company software, which can be used for managing, cleaning data, as well as data analysis. And we'll conclude with a summary and question and answer session. Our company Statistics Solutions provides assistance with every part of the dissertation process. So the way our company works is we have both methodologists and literature review specialists, as well as APA specialists. So we will assign a specialist to you depending on where you need assistance. So we do help with the proposal chapters, which typically involves the introduction, literature review, and the methodology. We do assist with both quantitative and qualitative studies. So we can help develop your research questions and hypotheses, calculate a power analysis so you can figure out what is the minimum sample size you need to target for your research. You can help figure out your data analysis plan to help address your research questions. What is the best statistical tool you can use to address your research questions? As far as the literature review, we can help you identify articles to support your research. We can help frame your theoretical framework and provide citations to guide your literature review. We also assist with IRB forms, data entry templates. We can host a survey for you on our own SurveyMonkey account. Then we assist with the results chapter, both quantitatively and qualitatively. We help with the final chapters of the process, which includes the discussion chapter, PowerPoints for defense, both proposal and final defenses, as well as journal publications. So if you'd like to take your dissertation and potentially condense it so it can be submitted to a journal. We can help you do that. So if you have any questions about the services that we provide, please give us a call at 727-442-4290. So for today's topic, we're discussing regression models, and it's important to lay the foundation with when to use a particular regression model. There are several different types. And if you have an understanding of the levels of measurement for variables, then you can easily pinpoint what type of regression you need to run. So there are three main variable types. We have continuous, nominal, and ordinal variables. Continuous variables are variables that fall on a continuum. So examples of these include test scores, like SAT scores, ACT scores, GPA, temperature, which is measured in Fahrenheit or Celsius, weight, in pounds or kilograms. Also composite scores. So if you are using a survey like the multi-factor leadership questionnaire or the job satisfaction questionnaire, you're usually using ordinal Likert scale items. And the idea is to make an overall score from that measure, either by taking an average or a sum of the Likert scale questions. Once you've done that, your composite score is now continuous. So that is a commonly used continuous variable. A nominal variable is one that has categories. So you have two or more categories. It's not numeric, but you have discrete groups. So examples of this: gender, ethnicity, or passing and failing of an exam. Notice that these don't have an intrinsic order. There isn't a hierarchy. You have discrete groups, male and female, white, black, Asian, Hispanic for ethnicity, and passing and failing of an exam. You have discrete possibilities. An ordinal variable is a subset of a nominal or categorical variable, but there is a ranking involved, or there's an order involved. For example, education is often considered an ordinal variable because you can go from high school, associates, bachelor's, master's, PhD. There's a natural progression to this variable, so it's considered ordinal. Another example is just a single item on a survey that uses an ordinal or Likert scale format, so strongly agree down to strongly disagree. This would be an example of an ordinal item. So from here, we can determine what is the best regression that you should use in your research. So there are three key types. We have a linear regression, and the type of regression analysis you choose is dependent on what your outcome measure is. Your outcome, it can be called an outcome variable, a criterion variable, or a dependent variable. They are all synonymous. They mean the same thing. So depending on how your criterion variable is measured is going to make the determination on what regression type you use. So if you have a continuous criterion variable, something like SAT scores or GPA, then you want to use a linear regression. Then we get into binary and multinomial logistic regressions. So binary means two possibilities. So if you had exam scores and it's a pass or fail for the exam, then you could use a binary logistic regression. You're trying to predict a variable that has three or more groups like ethnicity, white, black, Asian, Hispanic, then you use a multinomial regression. An ordinal logistic regression is used when your outcome or your criterion variable is an ordered variable, something like education, or if you're using one Likert scale question as your outcome that has possibilities like strongly agree, neutral, disagree, then you want to use an ordinal logistic regression. As far as the predictor variables, the same definitions apply. So continuous, nominal, ordinal, you can have those three possibilities as predictors. And I gave the same examples here as on the first slide. As far as coding for regression analysis, when you have continuous predictor variables, you don't need to make any adjustments to your variable. You're going to input it exactly as it is. So continuous variables as predictors are pretty easy and straightforward. It gets a little more complicated when you have categories or nominal ordinal variables. If you have a dichotomous predictor, you need to assign either a 1 or a 0 to each of the possibilities. And usually the absence of a condition is the lower of the values. So for instance, passing and failing of an exam, if that is a predictor, then you want 0 to be fail and you want 1 to be pass, so that everything that you're interpreting in the regression model is in terms of passing. Okay, if you have a nominal variable with 3 or more groups or an ordinal variable, then you need to do a process called dummy coding. So dummy coding, it's a little bit lengthy to explain in a webinar like this. If you just do a Google search on dummy coding, and on YouTube, there are a ton of videos that explain this concept in depth. But the idea behind it is that if you put a variable like ethnicity into a regression model, SPSS or R or SAS, they don't know, those softwares don't know what ethnicity means. It doesn't understand that 1 is white, 2 is black, 3 is Asian. So it's up to us, the researcher, to apply meaning to it. And the way that's done is through dummy coding. What you do is you take one of your possibilities here and you assign it as the reference group. Many times I see the most prevalent group or the highest sample is used as the reference. So as an example here, what you do is you take this one variable that has 5 possibilities and you create 4 variables out of it. So it's essentially then every race is going to be compared to white. You have black versus white, Asian versus white, Hispanic versus white, and other versus white. Essentially, we've created a series of dichotomous variables. Now you can interpret versus the comparison of the white ethnicity. This is the way you handle groups that have 3 or more possibilities. As far as the process for interpretation, you first want to check for the assumptions of a regression analysis. There are many citations on the internet. All have different assumptions to check depending on what reference you read. So you'll want to pick one citation and just be consistent in your methodology and your results chapter. Linear regressions have more stringent assumptions to check in comparison to logistic regressions. When you do a linear regression, you have to check for things like normality, homoscedasticity, absence of multicollinearity. When you do a logistic regression, you don't need to check for normality because your outcome variable is categorical. You typically check for normality only on continuous variables. The same logic applies to homoscedasticity. Absence of multicollinearity is used whenever you have multiple predictors, so it could apply to linear regressions or logistic regressions. So multicollinearity is making sure that your predictors are not highly associated with one another. So you can use tolerance statistics or variance inflation factors to check that assumption. As far as interpretation, once you've checked assumptions, you first want to interpret the omnibus test. So if you do a linear regression, that's going to be an F test. If you do a logistic regression, it's a chi-square test. And this is going to tell you if there's collectively a predictive model, if you have predictive strength in your model. And this is typically identified with a p-value being lower than 0.05. Then you want to interpret your coefficient of determination. If you're doing a linear regression, it's called a R-squared value. And if you're doing a logistic regression, it's a McFadden's R-squared. Step 3 is then interpreting each predictor on its own. So you only do step 3 if your omnibus test is significant. So you need collective significance before looking at each predictor on its own. And when you interpret each predictor, you want to use a t-test for a linear regression and a wall test for a logistic regression. And if you have a significant predictor, then you can interpret further with coefficients or odds ratios to tell you how does your outcome variable fluctuate based on a change in your predictor variable. I'll give you guys a demonstration in our company software Intellectus. This is what Intellectus looks like when you first open it. And what I'm going to do is choose an example data set here. And I'm going to choose this one right here. Okay, so once you've selected a data set, you can also upload your own data directly from SPSS, Excel, SurveyMonkey. You can upload your data into here. So this is what the spreadsheet looks like. And this data has a series of rows. Each row represents a different car model. And the variables of interest that we have miles per gallon, the number of cylinders, horsepower, weight of the car. So I'm interested in seeing if a series of predictors can predict miles per gallon. Okay. You can see all the data management functions we have on the side here. So you can reverse code, you can impute missing data, you can remove outliers here. And you can also create composite scores. So if you're using a Likert scale questionnaire and you want to take a mean of a series of items, you can do that here. You can also take a sum of a series of items. And we also have transformations. So you can, if your data is not following a normal distribution, you can transform it into a logarithmic, reciprocal, cubic, squared, and so forth. We also have plots, so you can create multiple plots. We have a decision tree in here as well, which will guide you in the direction of the right analysis that you need to use. So for example, today, we're using linear regression. So I want to predict an outcome. The level of measurement of the outcome is continuous or scale. Scale just means that it falls on a continuum. You have decimals as possibilities. It's a good way to identify a scale variable. So I'm going to use miles per gallon. So scale applies there. And we can see it goes down the decision tree and it's highlighted the choices we made. We need to use a linear regression to address this question. We also have data analysis plans in here. So this would be what would go in your methodology chapter. So regressions, linear regression. So we give a sample research question of what a linear regression is going to test. And we also give definitions of terms, what the regression equation looks like, what assumptions you need to verify, and the interpretation of the results, along with a series of references. So we have many different tests that you can develop a plan for. And we also have power analyses. So power analyses are used to calculate your sample size. So today we're doing regressions. And if we do a linear regression, you can see Intellectus provides 3 write-ups for a power analysis, depending on what effect size you are using. If you don't have research or prior research to tell you what effect size you need to use, then just go with a medium effect size. For the model today, I'm going to use 3 predictor variables. So I'm changing that up here. And you can see right now it's 55 participants would be ideal with 1 predictor. I change this to 3. That number is going to adjust. So 3 predictors now yields 77 participants as a minimum. So the way this is developed is we use GPower. GPower is a free software that's used for doing power analyses. So we've cross-referenced all the different numbers and analyses that you can use. And we provided APA write-ups for them automatically. Pretty cool. I'm going to go today under the Analyses tab to show you regression. So under the Analyses, you can see all the different options we have. We can do descriptives to start out. Typically, descriptives are used to start out a chapter. So you could just do descriptive on everything here. Confirm and calculate. This is going to give you, for categorical variables, it's going to give you a frequency table. So you can see how many V-shaped engines there were, 18 V-shaped engines, and those 18 cases represent 56% of the sample, approximately. Anything that is continuous, meaning really numeric, is going to give you means, standard deviations, the sample size, the minimum value in the sample, and the max. So for instance, miles per gallon, among the 32 cars, the average mileage was 20.09 miles per gallon. The lowest car had a 10.4 mile per gallon, the highest was 33.9. For the regression analysis, I'm going to go to regressions and linear regression. The dependent variable is what we're trying to predict. I'm going to select miles per gallon. And as predictors, I'm going to put in the number of cylinders, the horsepower, and the weight of the car. We can go to options at the top right here to see what assumptions are being checked. So we're going to check for normality with a QQ plot. We're going to check for homoscedasticity with the residuals plot, and variance inflation factors for multicollinearity. Save the options and click calculate. And just like magic, it's going to present a full APA write-up for this regression. So the first thing it does is it checks for the assumptions. So normality, ideally, we want the data to follow on this diagonal line. So there are some slight deviations from here, which could have to do with the sample size. So the sample size for this analysis is relatively small, 32 cases. So that could be a limitation for looking at the normality assumption. Homoscedasticity is looking for random spread and random scatter in the responses. So as you can see here, if you hover your mouse over the plots, it tells you ideally what the plot would need to look like to support the assumption. Homoscedasticity, we just want random scatter. We don't want to see a straight line or exponential curve or parabola. So we do meet that assumption. Multicollinearity, for this assumption to be met, and what this is checking is making sure that cylinders, horsepower, and weight are not highly associated with one another. If they are highly related, it causes a problem in a regression model. You want them to be independent, ideally. And we do have evidence of this. The VIFs need to be below 10. Okay. And that is supported. So that assumption is met. Then we jump into the results of the regression. So really the most important part here. And the first thing you want to look at is the note at the bottom of the table. The note is going to tell you, this is the omnibus test. Let's go back to the presentation. We're on this step here. And the first thing you want to do is interpret your F-test result and then interpret the coefficient of determination. Okay. So the F-test result is right here, and the p-value is below 0.05. If you hover the mouse over here, it gives you a definition of the p-value. So if it's below 0.05, we have a significant omnibus test. In this case, that means that cylinders, horsepower, and weight together do appear to predict miles per gallon. The R squared is right next to it, right here. And this is a percentage. If you move the decimal over right 2 spots, that's 84%. So 84% of the variance or the change in miles per gallon can be explained by the 3 predictors. So we have collective significance. We've verified this step is correct, or this step is significant. We've interpreted the R squared. Now we can do step 3. So because step 1 was significant, we can move to step 3. So now we want to look at each predictor on its own and evaluate if it's significant or not. So the way we do that is we dive inside the table now and go across the row for each predictor. And we want to look at this final column, the p-value column. You can disregard intercept. Intercept is just part of the equation, but it's not highly interpretable. We're looking at cylinders first. The p-value is 0.098, which is greater than 0.05. Likewise with horsepower, this p-value is greater than 0.05. 0.14 is larger than 0.05. So both cylinders and horsepower on their own do not have a significant predictive relationship on mileage. However, weight has a p-value below 0.001, which is lower than 0.05. So weight is a significant predictor in this regression model, and you can then interpret this value here. This is your unstandardized beta coefficient, is what I talk about right here. If the predictor is significant, interpret your beta coefficient. So because it is significant, what this means is that with every 1 pound increase in weight of the car, or with every, I believe it was in thousands actually, weight. So it's in metric tons, I believe. So this is really, if you multiply all of these by 2,000, that's what the weight is in pounds. So what this means is that with every 1 ton increase in weight, the miles per gallon decreases by about 3 units. Okay, so we have an inverse relationship because of the negative sign between weight and mileage. As weight increases, the mileage decreases, which is to be expected. Okay, so that's a linear regression. Another one we can run is a binary logistic regression. Okay, so what I'll do on this one is I want to see how miles per gallon can predict the transmission type, whether it's a manual or automatic car. So I'll go to binary logistic regression. The outcome needs to be dichotomous. It needs to have only 2 possibilities. Transmission type, and we'll keep the reference as automatic. The predictor will be miles per gallon, and calculate. So again, remember how I mentioned assumptions not being as strict for binary logistic regressions. The only key assumption here is that your outcome is dichotomous, which it is. Transmission type could be automatic or manual, so that assumption is met. It's not going to check for normality or homoscedasticity. If we added more predictors, then it would check for multilinearity. But we're just looking at one predictor right now. So what we see here is that we have a significant omnibus test. And note how the chi-square value now. So when you do a linear regression, it's an F-test. When you do a logistic regression, it's a chi-square value. So we do have a significant omnibus test or a significant chi-square. The McFadden's R squared tells us that 31% of the variance in transmission type can be explained by mileage. Then we go inside the table and we can see that the p-value is still significant. And we have the odds ratio. So the odds ratio is going to tell you how does transmission type change by an increase in miles per gallon. And this is also a percentage. So this is 36%. So with every 1 mile increase per gallon, the odds of the car being manual increase by 36%. This means, and that is interpreted right here. Every 1 unit increase in miles per gallon, the odds of a car being a manual category increase by 36% in comparison to an automatic car or an automatic transmission type. That covers a linear and logistic regression in Intellectus. That concludes our webinar for today. So just to reiterate, if you're trying to predict an outcome, just the word predict is usually indicative of using a regression model. And then you can have any variable type for your predictors. They can be continuous, nominal, or ordinal. The regression method you use will be contingent on your criterion variable. So remember, if it's a continuous variable, you use a linear regression. If it's categorical with 2 groups, pass and fail, you use a binary logistic regression. If there are 3 or more groups, then you use a multinomial logistic regression. And if your outcome is ordinal, then you use an ordinal logistic regression. You then want to check the statistical assumptions. If you're doing a linear regression, there are more assumptions to check. Then you want to follow the 3 steps for interpretation. And you can use Intellectus statistics to analyze your data, clean the data, and present it in an APA format. So thanks for joining us today for the webinar. I'm now going to do a question and answer session. If you do have any questions about the services we provide, you can email us at info@statisticsolutions.com or give us a call at 727-442-4290. All right, if you have any questions, you can type those into the chat box or the question and answer box. Do we have any questions? And we will be sending everyone a recording of this. You're welcome, Jennifer. Thanks for joining. Here I'm going to pull up a list of, on our company website, statisticsolutions.com. You'll see a webinar tab at the top, and you can see both the webinar archive. So this is going to have the past webinars we've done, and you can watch the recording on those. There are many recordings to watch where we do some that are tailored to a whole chapter. Some are specific about like conducting a power analysis or developing research questions. We also have a list of upcoming webinars, which I'm sure most of you have seen this already, but you can see what is on the horizon coming up. So it looks like tomorrow, Dr. Grabner is going to do a session on qualitative results. And then a couple weeks from now, we'll be doing qualitative methods and selecting statistical analyses. So let us know if you have any questions. All right, we have a question from Mary. I have a predictor and a criterion variable and two moderator variables. So I didn't really get into moderation and mediation today. I wanted to keep the foundation relatively basic, but we do have moderation in Intellectus. If you go to advanced, you can see moderations right here. The limitation here is that you can only select one moderator at a time. That may be a limitation to you, but the idea behind moderation is that you need to create interaction terms. So you need to multiply your predictor times your first moderator, and then multiply your predictor times your second moderator. You put those interaction terms in the model, and if they're significant, then you have evidence of moderation. If they are not, then you cannot support moderation. Essentially, you're just going to have to multiply your predictor times your moderators. Okay. If you do use Intellectus, you could do two separate models. You could look at one moderator at a time. So select your dependent variable, select your independent, and then just select one of those moderators, run the model, and then do a second iteration in which you substitute your moderator with the second variable. Okay, do we have any other questions? Any other questions? I'll stay on for about 5 more minutes. Any questions about what analyses to pick? What is the best regression type to use or level of measurement? Or what assumptions to check? A question from Larry. Can you code nominal variables so that each level is compared to the grand mean rather than a reference group? That's not something I'm familiar with. I also don't know how from a nominal variable you can have a grand mean. If you're if you're looking at reference groups and things like that, a categorical variable that has 3 or more possibilities, none of those possibilities can be numeric. I don't know how you would compare to a grand mean. Sounds like the process you're trying to do is dummy coding, which I did discuss briefly, but that's what I would do a YouTube search on, is just check out dummy coding. And we just had a question about receiving a copy. We will be sending everybody a copy of the recording and the PowerPoint slides, 1 to 2 business days. And any other questions? All right, everyone, thanks for joining us today. Let us know if you have any questions about the services we can provide, and come join us for our future webinars. Have a great evening. Take care.